All right, so let's get going on today's class. So today is going to be the statistics workshop, which I'll admit has the potential to be amazing and also the potential to be very intimidating on my end. So we'll see what we can do. Hopefully it'll help a lot of people out. I'll take questions in just a moment. But the first thing I want to do is I got some emails from some students. Thanks for sending those in. And there seems to be a couple of common themes that I want to make sure that everybody is aware of, that everybody kind of knows going forward to help with their stats. So what we're going to do first is the first common theme are the resources that you have access to in order to do your statistics. So I have seen a couple of students trying to do statistics and statistical tests in Excel. And Excel is useful, but it is not designed specifically for statistics. So I personally do not know how to do statistics using Excel, statistical tests, because I don't use Excel to do statistical tests. So is it possible? Yeah. Is it possible to do all that you need to do with pencil and paper? Well, statistics existed way before computers did. But what you want to do is you want to use the resources that you have, use the best resources that you have. And specifically, you're going to be looking for SPSS. That is the one that I highly, highly, highly recommend. Now, SPSS is something that is installed on the computers that we have here. So if you go to the psych lab, if you go downstairs to the to the computer labs, you will find SPSS on their computers. You also have the ability to access SPSS from home. So I don't expect everybody to do all their data analysis here at IUSB. So you can also access it at home, but I just want to make sure that everybody knows how to do that. So you do not want to go to IUware, to that software downloads, because in IUware, if you find SPSS, this is the resources that we have for you to download the program and install it on your computer. And if you do that for SPSS, you'll be asked to pay a subscription fee. And I believe it's like it's something like $60 or $80 for the year. But you'll be asked to pay a subscription fee to use that, because we just don't have the license to allow people to use SPSS when it's installed on their computer. So you do not want to go to IUware. For many other things, like if you need Microsoft Office or if you need Excel, go to IUware. You can install it on your computer. For SPSS, you don't want to do that. What you want to do is you want to go to IU Anywhere. And IU Anywhere is the cloud computing access that we have here at IUSB. And what this is for any programs that we do not own the licenses, or we have not paid for the licenses for you to install it on your home computer. We have paid for the licenses for us to install it on our servers, and then for you to have access to those servers as an IUSB student. So if you go to IU Anywhere and you click on Start, it'll take you to the login page. And I already got mine auto-filled. So it'll take you to the login page. And you get out your cell phone.
So
all right. I know. You don't know how long. I mean, I totally dislike this because I usually don't use this for productivity. So one of the first things that I do when I'm getting ready to get down to business is put it away. And then I end up being like, all right, I'll pull that out of the drawer or whatever. So anyways, when you get here, I already have SPSS. You can see it's the one program I use IU Anywhere for. When you get here, SPSS is probably not going to be in your favorites. So if you go to just apps and you just search all apps and you put in SPSS, it will show you that it's got version 24 and it's also got version 25. Either of those will work. So version 24, version 25, either of those ones will work. And then when you click on it, it will open up a connection between your computer, as long as you got internet and you have a Citrix receiver installed, and that is just, it'll prompt you to install it if you don't have it. It'll open up a connection between your computer and their servers, and it will run SPSS for you. And then this is what you want to use. This is the dedicated program for running statistical tests. So you can also see that, I mean, this is, again, what I've used when I run any of my statistics on my experiments and studies. So this is what you want to use. This is specialized for the your statistical analyses. The other great thing about SPSS is that it is widely used. And because it's widely used, it is also widely tutorialed on online. So one of the things that I literally did, I got an email yesterday about a data set, and the student was asking me, I think I need to do a correlation for this. How do I do a correlation in SPSS? And, you know, because I use SPSS all the time, I had no idea, because I don't do correlations in SPSS. That's not usually what my experiments are designed to use. So literally it was SPSS. You can see the autofills there from yesterday. So SPSS correlation, and it will pop up numerous tutorial videos. And this is literally what I need to do whenever I need to figure out how to run a test in SPSS. So you can just click on that, watch a commercial, and it will take you through, again, exactly how to do this step, all the way from like data setup to choosing, where'd that guy go? All the way to choosing which test to do. So go to analyze, go to correlation, go to bivariate, how to set up your data. So it's got all of that information. And then it'll also tell you how to read your outputs. So I highly recommend this. You can see in the PowerPoint notes that I provided as well. This is a program that I used when I was doing my ANOVAs and when I do my t-tests. So I highly recommend do this in SPSS because it is the easiest way to get those significant values. When you're using SPSS, and this is the second point that I wanted to make sure everybody knows. When you're doing your statistical analyses, in SPSS, you're going to need to figure out how to format your data. Again, check the videos for the test that is for your specific situation. But by far the most helpful piece of information is that each of these rows here is either for a single subject or a single case. So if you have multiple scores for the same subject, if you have subject number 10, all of subject number 10 scores go on row 10. If you are doing a correlation between countries, and row 7 is Canada's row, all of Canada's scores go in row 7, right? So if you're doing either by cases or by subjects, each case or each subject gets one row and only one row. That is the big, one of the big organizing principles. And then that's for SPSS. The last thing that I wanted to address that has come up a little bit is that for your data sets, you need to, for each and every variable that you have, come up with one number that is the score for your subjects. So this is going to be mostly for individuals that have done surveys where you have asked subjects 20 questions to measure their biases against, their biases against different genders. If you've asked them 20 questions, you cannot put 20 questions into SPSS and ask it to run an analysis. You have to boil those 20 questions down to a single score. So you got to take a look at your 20 questions and say, oh, all of these 20 questions measured bias, and I'm going to total them all up depending upon whether they're positively scored or reverse scored, and I'm going to end up with one number that is a measure of bias for this particular subject. So this one subject scored a 56, and that's it. This other subject scored a 48. This third subject scored a 12. right? You need to reduce your surveys, your measures, to a single measure for each variable. So if you're looking at the effects of anxiety on people's ability to complete a cognitive task, you might measure anxiety using a survey. You got to boil down those answers to one measure of anxiety. You think of anxiety as one score on a scale, you got to put them somewhere on that scale. And it's the equivalent of if somebody asked you how much do you weigh, you wouldn't say something like, well, my right forearm weighs 5 pounds, my left forearm weighs 5 pounds, my right thigh, we're looking at about 18 and a half, my foot, I'm thinking about 3. You give them one score, right? You add it all up and you say, I'm not going to say, but you say it, right? You say what you weigh. Same thing with your surveys. You got to boil it down to one score for each variable that you measure. There's a hand?
So you're saying do a sum of all of them, or like an average, or is it an average?
Well, you can do, it doesn't actually matter. So you can do a sum, you can do an average. The key there, though, is to take a look at how your survey is scored. So make sure that if you sum things, you are summing them up correctly. Mm-hmm. So for example, if you were, I wonder if we have any. Of course. If you were doing something, if I was doing a survey on people's attitudes towards statistics, and I said on a scale of 1 to 7, right, how much do you love? How much love for stats? Right? And people are like, oh, that's going to be a 2, right? I circled a 2. If I then have a question later on where I'm like, how much hate for stats? 1 to 7. And they're like, oh, 7, right? If I'm scoring this, I can't just add these two together. I got to reverse score them. So make sure that the questions that kind of increase love are positively scored, the questions that decrease it are negatively scored. Right. And then you can sum the whole thing. And that's a little bit easier than taking the average of it. So that's what you have to do, but I need to get one score for this. So check out the ones if they're reverse scored. Right. If you're using a survey that's been established, sometimes they have scoring keys that'll help you score it as well. But basically, you need to boil it down to one number.
And then my other question is, so what happens when you have neither agree nor disagree, where that could affect, like, say people are keep answering at like a 4, which would mean neither agree nor disagree or unsure. Yep. And their average is 4, which doesn't mean that they don't hate it nor love it. You know what I'm saying? That can affect it, even though they're not actually having an opinion on it.
Yeah, and that's their score. Okay. That's where they're at. So if they're basically indifferent, then that's the score that they achieved, and we don't have to worry about that. Now, one other thing that I will mention on that is do make sure that you take a look at your data and take a look at some of the scores, some of the answers, and just see if they make sense. Because you don't want to include answers that are very clearly couldn't possibly be the case. So this isn't going to happen in a lot of your studies, but if it does, just sort of, it's always a good idea to kind of take a look at your data, kind of plot the data, see what the see what the relationships are. And what I mean by this is, if you ask somebody how many hours a day do they spend watching TV, and the answer is 20. Well, it's quite possible that you got a TV addict on your hands, right? That's within the realm of possibility. Maybe they exaggerated how long they spend watching TV. That's a lot, but it's within the realm of possibility. But if you ask them how much time do you spend per day, and they answer 25 hours, get rid of that data point, because that is clearly wrong. So we can have criteria for rejecting subjects. The clearest criteria is that their answer is impossible, right? Sometimes on surveys like this, they'll have catch questions that they'll put in the survey. So for example, if I was scoring this, and I had a question that says, how much do you love stats? And they said, oh, 7 out of 7. And then I had another question, how much do you hate stats? And they're like, oh, 7 out of 7. That subject's gone because they're not reading my survey. right? Or they're lying, or they're not paying attention. Something's going on. So double check your data and just kind of, take a look at it, see if anything seems fishy. But what you're not allowed to do, what you cannot do, is get rid of a subject because you don't like the way that they answer things. So I've had subjects where they put answers that went totally against what everybody else was doing, and I didn't get rid of them because it seemed like a valid answer. They were weird. They were definitely outliers, but we can't get rid of them just because we want to clean up our data. We can get rid of them, though, if things like that occur where it makes no sense, right? You love stats and then you hate stats. You're not reading the survey. That's what's going on here. All right. Other questions, and we'll see as they come up. Has anybody run their stats? Okay. And everything worked out? You can interpret the output and everything?
I hope so.
You hope so? Okay. So basically, do you use SPSS?
I did, yes.
Okay. So for those of you that haven't read your haven't done your statistics yet, what you're going to end up with. Let me see if I can just make up some data here. Nope. All right. So if you run your statistics, you can. In this case, I'll do the correlation on this one. So if we go to analyze, we go to regression. Well, not regression. Correlate, and we go to bivariate, and we got those two variables, and we're going to do a Pearson correlation coefficient. All right, so for your outputs, basically what you are looking for, the key thing, and they will, outline size, that's the outline. 1 second, we'll try to zoom in on this. Yay. All right, so the one thing that you are looking for, the big key thing that you are looking for is this significance value. So this is the output for a correlation. And this gives you, and again, check the tutorials on SPSS. The only reason I know this is because I watched that video yesterday. But this is going to give you the output that you need. Make sure that you take a little bit of time to try to determine what it is that you need to look for. So one of the things about SPSS is it will throw a lot of numbers at you. Don't get overwhelmed with the numbers. And take a look here, and this correlation over here, that's the correlation coefficient between variable 1 and variable 2, and that gets a significance of 0.005. That is less than a 0.05 alpha. That is a significant result. So somewhere in your analyses, whether you're doing a regression, whether you're doing a correlation, whether you're doing a t-test, whether you're doing an ANOVA, or any other statistical chi-square test, anything like that, the number that you're looking for and that kind of be-all and end-all number is going to be that one right there. And that p-value, usually called significance by SPSS, that p-value is what you're looking for. And if your p-value is less than 0.05, which is typically the alpha level, then you have a significant result. Something is weird about your data. Something is, there's an effect for your data. So for my made-up data here, if you can appreciate the skill of making up a correlation on the fly that's not equal to 1, thank you very much. But anyways, my made-up data here has a significant correlation. These two variables go together. So that's what that significance means. And then what you want to do is you want to then tie that back. So that goes into your results, and then you tie that back into your discussion section, and you make your implications. Now, one thing that I've also kind of seen, and I've seen this a little bit also in the some of the URC abstracts, is that when you get a significant result, it is one of the best feelings. You put in all the work, you've made all the predictions, you run your data, and lo and behold, it's that p-value that's less than 0.05. Oh my goodness, you know, all my dreams have come true. When you don't get that significant value, it's not the end of everything. And I find oftentimes that students kind of say to themselves, oh, it's not significant. That's not the, that's the end of everything. And what's going on there, and this will kind of help you with your write-up for your discussion section, is the reason it's a little bit more difficult to address a negative result, right? The reason that it's a little bit more difficult to address when you don't find something is because when you do find something, there's only one reason why you found that something, and it's because that something actually exists. All right. So let's say, and this is your typical example. Let's say that I was wondering, do white swans exist? Right? I was just wondering, does a white swan exist? And if somebody came to me with a significant effect, which means that they came to me and they said, hey, take a look at this animal that I have. It's a white swan. Then I've answered my question. Do white swans exist? Here's a white swan. Yes, it exists. So when you're looking at stats and you're saying, is there an effect? And you get that p-value, it's less than 0.05, that statistic's saying, we found an effect. We found your white swan. If, on the other hand, I'm faced with a situation where I'm asking myself, is there a white swan? And in my exploration of this world, I have never seen a white swan. That's the equivalent of getting no effect for your stats. And the reason that's a little trickier to deal with is because there's two reasons why it could have happened. Number one, and this is the interesting reason, there are no white swans, right? So maybe I didn't find a white swan because there are no white swans. They don't exist. That would be huge. Could you imagine my status in the biological world if I could prove that white swans don't exist, right? That would be a huge finding. The other possibility, though, is that I didn't look enough. So if somebody said, oh, you didn't find any white swans? And I'm like, yeah, I never found any white swans. And they're like, well, where did you look? And I said, well, I looked in the men's bathroom, and there were none there, so I concluded no white swans. It would say, well, that's not enough. So there's always that possibility when you don't find something that you just didn't run enough subjects, right? You just didn't look hard enough. You didn't look in the right areas. You didn't collect enough data. So there's always those two possibilities, right? Those possibilities go away when you found something. Because if you found something, clearly you've looked at enough data. But if you don't find something, maybe it's not there, or maybe you haven't collected enough data. So things that I want you to think about if you don't find something is, number one, are you likely to find something if you continue to collect subjects? So let's say, for example, I was looking at a difference between two groups, right? I got group A and I got group B, all right? And my prediction is that group A should score higher than group B, all right? That's my prediction right there. That's what the theory said should occur. And I test my statistics, and I don't get a significant result. So all of this is going to be about me not getting the significant result. If, in fact, I look at my data, and my data is in line with what I should have, what I predicted I would find, right? So I predicted A should be greater than B. And I can't, and I actually found in my study A is greater than B, but it didn't quite reach significance. You can still argue from this. We don't lie. We don't say, oh, I found a significant finding. But we can say findings were non-significant. However, they were in the predicted direction. So it does tell us a little bit. It tells us maybe if we had, 20 more subjects, we would have gotten significant results. Maybe we would have had enough power. So don't just dismiss it and say, this means nothing because it's not significant. No, we got data. It's in the correct direction. especially if your p-value is close to that 0.05. This is called a trend. It's a trend in the right direction. You can argue from that. Let's say, on the other hand, that we found, again, a non-significant result. But this time, instead of A being higher than B, this time A is lower than B. Even if we didn't find a significant result, this is extremely interesting and important on its own. Because what this is saying is that even if we ran 20 more subjects, it is highly unlikely that this is going to flip to what we predicted. So this can be seen as a disconfirmation or a refutation of the theory. The theory I was testing said A should be higher than B. We actually found A was less than B. This kind of data usually indicates that if you were to run another 20, 30, 40, 50 subjects, if you ran another 100 subjects, this isn't going to flip. So if you have data that goes in the opposite direction of what your theories predicted, that, even if it doesn't reach significance, is still good evidence that your theory is wrong. Your theory wasn't able to predict what was going on. And the only one that is kind of not as convincing as the others is if you kind of find no difference between the two. It's not significant. They're both kind of at the same level. This has the real possibility that if you ran more subjects, the story would change. So those are your possibilities. So again, take a look at your data. If it comes back non-significant, ask yourself, is it close? Is it in the right direction? In which case we have what's called a marginally significant trend. Is it in the complete opposite direction? In which case we have evidence that the theory is wrong, right? It's gone in the complete opposite direction, even if it didn't reach that statistical significance. All right. Any other things, any other issues people are coming up with? Their statistics, interpretation of stuff, things like that? Does everybody kind of feel like they know what it is that they're going to be running, if they haven't already? I'm going to take, yep.
I have a couple options to do it, but I was going to ask if I should do this test or this test.
Okay.
To get more details kind of thing. I have the data available for either one.
So what are your two options? Let me see if I think they are what they.
The popular versus like the unpopular percentages, but I also have the types of reviews available where I can like see which type is more.
Oh, okay. Yeah.
I have both of those.
So in that case, it's a good question. So we got popular versus unpopular. And then you have the levels of abuse. And then you also have those levels split up across type of abuse. Okay. So one thing, the thing that you could do in that case is, and you're splitting up popular versus unpopular into two separate groups?
Yes.
Okay. So what you have in that case is you have, I remember where I put my chalk every time I drop it. What you have in that case is you have one variable that is, you got independent variable A, and that is popularity. And that we'll just call high versus low, right? So we got that single variable. Your other variable is type of abuse. Right? So we got type. What are your types?
I have 5 different.
You got 5. Okay. So you got the 5 different types of abuse. All right. So this is the setup right here. What you're going to want to do is you're going to want to do an ANOVA. So you got 2 variables. They're not continuous. Right, variables, especially this one here is not continuous. You can't say that verbal abuse is more abuse than physical abuse, right? Or emotional abuse is more or less. So we got these non-continuous variables. This would fall into an ANOVA. And basically, what you would do in this case is you would run it like this. And the one thing that you would want to take a look at is it's going to take a look at high versus low, and it's going to average these numbers here when it's comparing high versus low. So the first thing you want to make sure of is that these are comparable. So in discussions with you, I know they are, because you were doing percentages of the panels, so they're comparable. The next thing you want to, that you're going to find is you're going to find when these are averaged. Do high popularity characters have more abuse than low popularity characters? You're also going to, in that analysis, find out if category 1 of abuse is more used than category 2, is more used than category 3. It'll make those comparisons as well. And then the last thing you're looking for is you're going to find a popularity times type interaction. So it will let you know if highly popular characters tend to have more of number 5, whereas unpopular characters tend to have more of number 2. So it'll also do those comparisons. But that's what you're going to be doing. You're going to be doing the ANOVA. And it's going to be, let me just pop that in here. All right, so let's get rid of that. Let me see here. So if we have, let's call the ones popular. Let's call the ones unpopular. Let's call the twos popular. When you're running an ANOVA in SPSS, you can't name them words. So we couldn't go, pop for that, non-pop for the other one. Let me just clear that out. We can definitely put a second line here, a second column, just so that we have that for our own minds. All right, so that's popular, that's non-popular. But we're not going to be analyzing those. And then what we have here in this, in these further rows here, these are going to be the types of abuse. So let's say that the percentage, we'll do this in percentages. So let's say that's something like 32, 45, 56, 23, 10. Is that 5 of them? Yeah, that's 5 of them. All right, so just for my own sanity, I'm going to call this abuse 1, abuse 2, abuse 3, abuse 4, abuse 5. All right, and this is popularity. Let's call that popular. All right, so this is going to be the setup. And one sec here. What? Oh no, sorry about that. Ran between. Here we go. Okay, trying to do this on the fly. All right, so 1 subject, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Data for 13 subjects. 13 subjects. All right, so do it. Let's give me that one more try. Control C. Trace values. See if that'll work. Oh, come on. Ah, all right. Copy. You are kidding me. All right, one last. All right. We are going to do this the old-fashioned way. What's the point of knowing all those if you can't use them every once in a while? So that's 5 of those. Excuse my percentages that are higher than 100. That is just massive amounts of abuse for particular female characters. All right. Okay, so let's say that that's your data set right there. So what we got is we got the popular characters. And again, notice every character in this case, every case gets their own line. So if number 1 is Wonder Woman, then all the counts of abuse that were depicted against her go in that row number 1. If number 7 is Lady Deathstrike, every single depiction of abuse for Lady Deathstrike goes in that line right there. So then we would go to analyze, and for this one we would go to general linear models, and the one that we're looking for is repeated measures. And repeated measures is the ANOVA that allows you kind of counterintuitively to do repeated measures or mixed models where you have between subject measures and within subject measures. So they put it in repeated measures, so that's the one that we're looking for. And then here for the factor name, we have the within subject factor. This is the variable that everybody got tested on. This is the variable that everybody shares. So this variable would be abuse. And in this case, we have 1, 2, 3, 4, 5 levels of abuse, 5 categories of abuse. So we would put that into our within subject factor. If we had another within subject factor, we would put that here as well, but we only got the one, which is a type of abuse. So we then go to define, and here on this wizard here, it's asking us, hey, you told us you got 5 levels for this variable called abuse. Which of your scores are those 5 levels? So the 5 levels are the ones that previously were labeled abuse 1, abuse 2, but now they got relabeled as var 00011, var 00012. So these are the scores of abuse right here, right? Those are the names. So we pop those into our within subjects factor right there, and we have our 5 levels defined for SPSS. The between subjects factor down here, this is the variable that not everybody shares. This is the variable that got split between different cases. And in this case, that variable is their score on popular, because not everybody scored a 1 and a 2 on popular. You were either in the 1 category or you were in the 2 category. So we're going to take popular and we pop that into between subject factors down here. And then the last thing that we want to do in this situation here, you can explore model, contrast, plots, post hoc, save if you want to save this analysis. But the last one that we absolutely need to do is this options one right here. And an ANOVA is an amazingly powerful tool, but it kind of leaves you hanging unless you ask for what are known as post hoc analyses. So if I ran this ANOVA without a post hoc analysis, it would tell me if there was a main effect, if there was an effect of abuse type, right? So it would say if there was a significant difference in the types of abuse that were depicted. What it would not tell me is where is that difference. So it would say, oh, one of these is different than the other ones, at least one. And if I didn't ask for post hoc tests, it wouldn't tell me which one. So you can imagine how useless this would be, right? You can imagine working for a drug company and they said, oh, did you test those 5 new drugs? And you're like, yeah. And they're like, and? Oh, and the ANOVA says one is significantly good at curing cancer. And they're like, which one? You're like, I don't know, but it's one of the 5. I can tell you that. It's useless. So we need to go to options here. We need to go to this compare main effects. And then we need to choose these post hoc analyses over here. Now the LSD, don't do that because that does nothing. That's like nobody uses that one. You can either choose Bonferroni or SIDAC. They're both widely accepted. They got pros and cons, but they're usually good in just about any of the situations. I prefer SIDAC. It's kind of like the newer one that is a little bit more powerful than Bonferroni. And then for this display here, typically I go descriptive statistics, estimates of effect size, and observed power. Do not click on all of it because you will end up with 80 pages of output and you will not know where to look. But these 3, descriptive statistics, those will give you the means. Estimated effect size, that is often reported now in APA style papers. Observed power, this lets you know how likely you were to find an effect if an effect was there, also pretty good. And that's about it. So we hit continue, we hit OK, and we get our output here. So what we're going to do, let me zoom in on this. Okay, so we asked for descriptive statistics, and that's what this first table is right here. So it's letting us know that out of the popular versus unpopular category, I gave them 6 individuals that I classified as popular. I gave them 7 individuals that I classified as not popular, 13 total. This is just a good page to double check to make sure that you didn't mess up when you were entering your data. It gives you the averages, for, it gives you the averages for popular individuals on the first type of abuse, unpopular on the first type. Averages for popular individuals on the second type of abuse, unpopular individuals on the second type. And then just averages for the type of abuse as well in general. So those are the descriptive statistics. The one that we really want to get to is I just want to make sure I'm on the right page here. The one we really want to get to, skip the multivariate tests. We want this test of within subject effects, and they have, let me see if I can get my page set up. Let's do that, landscape. There we go, because they cut off my stuff. All right, so we need, for this multivariate test, no, multivariate test we're not doing. Test of sphericity, we don't have to worry about. Test of within subject effects, this is what we're looking for. All right, so the test of within subject effects are only going to report the variables that are within subject or interactions that have within subject. So you'll notice that it reports abuse right up here. It reports abuse is interaction with popularity. But popularity by itself is nowhere here. That's because this is a test of within subject effects. The test of between subject effects is going to be right there, all right, on the next 2 pages. But let's take a look at it within subject effects first. So we take a look at abuse here. And when this is alone, what this is asking is amongst the different types of abuse, was one of them used more often than others? So it's totally excluding the idea of popularity. It's totally ignoring the differences between popularity. It is just saying, for abuse, was one type of abuse used more than other types? And we go over here to this, stay in the top row. Don't worry about these other 3. Stay in that top row, sphericity assumed. And we go over here and we see our F statistic. We see our degrees of freedom. We need those when we're reporting our statistics. But importantly for us, we have this significance value of 0.34. That is higher than alpha. That means that this is a non-significant difference. That means that in depictions of abuse, physical abuse and emotional abuse and verbal abuse, those were all used at the same levels. There was no difference amongst those levels. Abuse times popularity. This is the interaction. This is asking, are the levels of abuse that are used different for popular characters versus unpopular characters? Once again, sphericity assumed, stay on that top row. We go over here, we got the degrees of freedom, we got the F statistic, and we got the significance here. Once again, not a significant difference. No difference between how abuse is depicted for popular versus unpopular characters. And then we finally go to test of between subject effects. And once again, the significant data is hard to randomly make in your head. But once again, now we have popular by itself. Now we finally have this variable by itself. 1 degree of freedom, there's a death statistic, non-significant, meaning that popular characters were not depicted as being abused more than unpopular characters. Now, this is made up data. Your data for sure is going to look different, but this is the analysis that you're going to want to do. And then let's say that this was significant. Let's say that the popular variable had a main effect of popularity. Let's say that it was significant. Well, right off the bat, we know where that difference lies. It's in the high versus low, because those are the only 2 categories. We don't need to do any post hoc analyses. But let's say that we found a main effect for type of abuse. Now what we have to ask ourselves is, where did that type of abuse come from? So we're going to go down to this table here that is going to do those post hoc comparisons. And it's going to, you're going to find a table here that literally has these pairwise comparisons. And what this table does is it does a post hoc analyses comparison that controls for making multiple comparisons. So multiple comparisons get problematic when you make a lot of comparisons. It's kind of like somebody flipping a coin over and over and over again. It's kind of like if they say, oh, should I, are we going to go out and see Captain Marvel tonight? Or are we going to go out and see the other Captain Marvel, Shazam, right? Which one are we going to see? Well, let's flip. Heads, we go see Captain Marvel. Tails, we go see Shazam. And they flip it, and it's tails. And they say, let's flip it again. And they flip it again, and it's tails. And they go, one more time. And they flip it again, and it's tails. And they're like, how about one more? And they flip it again, and it's heads. And they're like, all right, Captain America. It's the same thing when you're doing multiple comparisons with stats. You can't keep going back to the well with that same coin and flipping that same coin. So what these post hoc analyses do, what that SIDAC post hoc analysis does, is it corrects for those multiple comparisons. It basically says, all right, make your multiple comparisons, but I'm going to correct for those probabilities so that I'm going to allow you to make multiple comparisons. That's what it does. It'll give you a table like this. It'll give you, most importantly, the significance levels right here. And these are the ones that, if it's less than 0.05, you got a significant difference. But the way that you read this table is it will give you every single comparison that you have possible. So it is comparing level 1 with level 2 of abuse, saying that there's no difference. It is comparing level 1 with level 3, saying that it's no difference. It is comparing level 1 with level 4, no difference. It is comparing level 1 with level 5, no difference. And you'll notice that it's redundant here. So comparing level 1 with level 2, look at that significance value, 0.612. No surprise, comparing 2 with level 1, look at that significance value, 0.612. So part of this, half of this table is redundant. It's literally saying, oh, is there more of abuse 1 versus abuse 2? No. Well, how about is there less of abuse 2 versus abuse 1? No, of course no. It's the same thing. So don't get thrown by the fact that it's a little bit redundant. Sometimes that gets a little bit confusing. But basically what you would want to do in this output, and your challenge is going to be, if there are differences, to kind of, especially if there's a lot, to kind of summarize it in a way that people can understand. Because literally, you're going to take a look at is 1 different than 2? Is 1 different than 3? Is 1 different than 4? Is 1 different than 5? Is 2 different than 3? Is 2 different than 4? Is 2 different than 5? Is 3 different than... Is 3 different than 4? Is 3 different than 5? Is 4 different than 5? And then you can ignore 5. You don't have to do that last one. So if there's, typically what people do in that case is they will mention the ones that are different, and then they'll have a blanket statement that says no other comparisons, reach significance, or no other comparisons were different. If you end up with massive differences all the way around, you do have to, report all those differences. So try to summarize it as best you can, like abuse level 1 was greater than all other, levels. It can get challenging, but try to write it out as best as you can. You have to report it. In the results section, you don't get to gloss over and say, oh, I'm just going to pick the ones that, are very interesting. Now, in your discussion section, you get to do that. So if in particular, physical abuse versus verbal abuse was something that you were particularly interested in or looking for, then it's completely doable and valid in the discussion section to say, we're going to focus specifically on that significant difference. But that's basically what your output is going to look like. All right, so that would be a full analysis all the way done. Oh yeah, and I do like that. You can see it right here, the SIDAC. So nicely, if you forgot what you ran, because in your results section, you'll notice in those APA examples that I gave you, you do have to mention, a SIDAC analysis or post hoc comparisons with SIDAC analysis, post hoc comparisons with a Bonferroni correction were done. It reminds you in case you forgot what you did. And it also says this is the adjustment for multiple comparisons. That's why we need to do it. All right. Anybody else? Any other questions? Yep.
Okay, so I had the 2 surveys that I did, and for each subject I did a sum of the values, and then I also did an average of the values because I didn't know which one to use for figuring out a scale that determined, like if you score this, you are like you have a higher tendency to perform, or if you score this, you have a negative attitude or a positive attitude. I didn't know what numbers to choose and how to figure out what numbers to choose for scoring those scales.
Oh, okay. So you're going to be comparing those 2 scales? Mm-hmm. Yeah. The short answer is that it doesn't matter. So as long as your scales, the relation between the scales inside the scales stays the same.
Oh, okay.
Do you know what I mean? So for example, if you code it as what was the one that was percentage, and one of them was percentage, right?
Well, I had for both of them I did Likert scales.
Likert scales.
Yeah.
Oh, okay. So if one of your surveys is potentially out of 60, and the other survey is only potentially out of 21.
Out of sum.
Right. Yeah, a sum. Right.
Yeah.
If one is maybe out of 60, one is only out of 21, you can still compare those 2 if you're looking at, is this one related to this one? So it's kind of like comparing height and weight. They're on 2 completely different scales. And yet, if we were to gather data on the heights and weights of individuals, we would find individuals with higher weights typically are taller. Individuals that are shorter typically are, way less. Even though they're in pounds and inches, that's totally fine. So you don't have to worry about your 2 surveys being on different scales. The ANOVA.
I was gonna do the
multiple regression.
Yeah.
It'll take care of it. It will factor that in. So if you're doing it as like, sums or averages.
Yeah.
And you can try this for yourself. If you're just kicking around and if you have some free time and you just want to do some stats, run it once with the sums.
Oh.
Run it once with the averages.
And see if
your outputs will be the same.
So I don't actually.
You don't even have to see. I'll tell you right now. Your outputs will.
Okay.
Yeah.
So I just have to have either the sums or the means for the scores. Like I don't have to, because I remember you sent an email, decide what your -12 would be this attitude, 10 would be this attitude. I don't have to pick that as long as I have the sums or the averages in.
Yeah.
Oh. Okay.
Yeah. So what I meant by that is because you have positive attitudes, you have negative attitudes. You were classifying people on positive and negative.
Right.
So one way that you can do that, I don't know how your survey worked, but if a negative attitude, so if people with neutral attitudes scored a 0, and people with negative attitudes had scores that were negative, people with positive attitudes had scores that were positive. Using that scale as the scores on your variable in a multiple linear regression, totally fine.
Oh, okay.
If on the other hand you say, oh, I'm taking the sums, so a score of 0 is the worst negative attitude you can have.
Yeah.
A score of 100 is the best positive attitude you can have, and you'll be somewhere in between those.
Okay.
That's completely the same. It'll give you the complete same.
And do I have to put
scores.
that into it? Like this is the lowest possible score and this is the highest possible score?
In SPSS?
Yeah.
No.
Oh, okay.
No. What you would want to do, so SPSS doesn't need to know what the scale is, doesn't need to know what the max and the mins are. It basically just takes a look at the numbers that you have and looks if there's a relation between, the two of them with whatever test that you're doing. Now, in your results section, I would highly recommend that at some point in your results section when you're discussing how you came up with the scores, so if you're taking the average of their scores on the survey, say that, to calculate measures of conformity. We took their average on their scores on, or their answers for this particular survey. And then indicate what higher scores mean. So it's always very nice when they say, oh, we took the average of their scores on this survey, with higher scores indicating more conformity and lower scores indicating less conformity. Because sometimes you don't know which way they're going, so that's a nice sentence to have. You don't have to tell SPSS. There's actually nowhere to put that in.
Oh.
Yeah.
Wow, that makes me feel so much better.
Yeah.
Great. And then my other question was, so I had the conformity and then I had the, I reverse scored a scale that I found that measured positive attitudes toward individuals who are gay and lesbian so that it would be measuring negative for what I was doing. And then I had like several questions about specific church beliefs and whether or not they believe, like they agree with their churches. So I was confused on how to navigate through those ones. Like my questions were, my church would support gay or lesbian pastors. My church would support gay or lesbian legal rights. So I didn't know what to do with those questions because I was thinking about comparing the two scores, like each question, because I only had 7 of those. I didn't know if I should try to put all those questions into one score, like you said.
So you have one variable that was how much do they conform to their church, and then you had another variable that asked what are their church's views on gay and lesbian individuals. Okay, so what you would want to do in that case is you would want to have one score for conformity to the church, right? And you would have either high or low. On a scale of 1 to 10, how much do they conform to their church, right? Or whatever your survey's out of. Low scores equals low conformity, high scores equals high conformity. Then you have attitudes of the church toward gays and lesbians. Low scores mean, is there a low score?
Yeah, I did a Likert scale for that one.
Okay, so what does a low score mean?
I have to go through, I was probably low score, like higher score would be negative attitude. I didn't reverse score those yet though. So
if you do it, lower score, negative attitude, higher score, positive attitude toward gays and lesbians. So in that case, you're going to have one row of conformity to the church. You're going to have another row of church's opinions. And that one is actually your, the tricky thing here, and this is why you're running your multiple linear regression, is that conformity alone is not going to predict their attitudes, because if they're high conformity to their church or they're low conformity to their church, we cannot predict their attitudes until we know what their church actually says, right? So if they're high conformity and their church is positive towards gays and lesbians, that would mean one thing. If they're low conformity and their church is positive towards gays and lesbians, that would predict another thing. If they're high conformity but their church is highly negative, then that would mean another thing. So this one I think is a little bit tricky to wrap your mind around, because you're not looking for the main effects, you're looking for the interaction. So when you run your multiple linear regression, what a multiple linear regression does is it fits an equation to your data, and it looks for the different contributors, the different predictors to your data. And they're typically Greek letters, so I'm just going to do A's and B's. So you have, what's the dependent measure? Your subjects?
Oh, conformity.
No,
oh, I'm measuring attitudes.
Measuring attitudes.
Yeah.
All right, so you got attitude. And you're going to try to predict attitude using these various other measures. All right, so you're going to have attitude equals A times your conformity level, right? It's going to try to fit an equation to your data. And it's going to say, all right, we took the conformity levels, and to fit that equation so that it predicts attitudes, we're going to multiply it by this coefficient. Those coefficients are your statistical analyses. That's what you're looking for. And we're going to add to that B times their church's attitude. Okay? That's your equation so far. A is probably going to be meaningless, right? Because levels of conformity doesn't tell you anything until you know what are they conforming to. B is probably going to be useless because what they're conforming to doesn't tell you anything unless you know what their levels of conformity are. But that's why you're running the multiple, because the multiple is also going to include an interaction term, an A times B term, that takes a look at conformity times church attitude. And this is the one that you're looking for. You're looking for what is that A times B? What is the, is it significant? So is there a significant interaction that predicts attitude? Where if you have high conformity and a high score, highly positive church, you're going to have high attitudes. If you have high conformity and a low positive church, you're going to have low attitudes. If you have low conformity, it'll take care of that interaction term. So that's why I think you might have been a little bit wondering about how to handle that, because when you run this, just kind of thinking about just the design of it, you're probably not going to get anything there, nor would we expect it. You're probably not going to get anything here, nor would we expect it. This is the one that you're looking for, that you might get an effect for. When you do see a significant, if you do see a significant interaction right there, then what you're going to want to do is you want to plot out the the interaction here, and just sort of, I think at this level, just sort of visually take a look at what that reaction, what that effect is. And what I would imagine is that you're going to have something like attitudes for positive churches or negative churches. You're going to have this for your low conformers. You're going to have this for your high conformers. And if this is significant, this term will be significant. And that's what you're looking for in your multiple regression output.
Okay.
Yep. Yeah, multiple regressions can get rough. The other thing that you're going to want to help yourself out with this as much as you possibly can is in any multiple regression, always try to code your data so that higher scores mean higher things, lower scores mean lower things. So for example, the way that you were mentioning, attitudes, high scores indicate positive attitudes, low scores indicate negative attitudes. That's going to help you interpret your regression, because these coefficients here, they're going to indicate, especially these ones here, they're going to indicate the direction of the effect. So if A over here is negative, that means that as conformity increases, attitudes decrease, right? If this is positive, that means that when conformity increases, attitudes increase, right? That's the way that this equation works. The worst thing you can do for yourself is code conformity in a negative way, so that a negative coefficient means a decrease in negative conformity, which is an increase. You don't want to do that to yourself. So make sure that before you do the analysis, code it in a way where higher numbers in your scores actually mean higher things. All right, we got about 5 minutes left. Any final kind of questions, issues, stuff? All right. So just, one last thing that I'll mention in closing is all of these tests that you're doing, they need to have one dependent measure that you're testing. So you'll notice here, we can test as many causes as we want. We can put in conformity. We can put in church attitude. We can put in distance to your church. We can put in years that you are at a church. We can put in anything that we want. But all of it, all of these independent variables are being used to predict attitude. And that is our dependent variable. So you can put in as many independent variables as you want, but they're all in service of predicting that one dependent variable. If you have a second dependent variable, let's say that you measured attitudes with a survey, and then later on you also measured attitudes by the length of time that they would engage in a conversation with a gay or lesbian individual, right? We're just looking at how long would they do it. If you have that second measure, you run another analysis. You do the exact same thing, but instead of using your attitude scores, you use the length of time. So I know that some of you do have multiple dependent measures. You're like, ooh, I measured anxiety like this and like this. Ooh, I measured, cognitive abilities like this and like this. If you measured your dependent variable two different ways, you're going to run two completely separate statistical analyses. The nice thing about it, though, is because they are in the same experiment or in the same study, it's going to be the same test. So you will literally just go here and say, oh, instead of looking at levels of abuse, I'm going to do this exact same analysis, and I'm going to substitute for levels of abuse. I'm now going to substitute in severity of abuse. Let's say that was your dependent variable. It's still an ANOVA. It's still got 5 levels, right? It's still the exact same test, but you got to run that second test. You can only do the one dependent variable at a time in most of these tests. The one where you can do multiples is correlations, because correlations don't have a dependent variable. They just have just a multitude of variables. So just bear that in mind if you're wondering, oh, how can I combine, the literacy tests for cognitive ability with the mathematical tests for cognitive ability? How can I get those down to one score? You can't. You shouldn't. Run 2 tests. They're 2 separate dependent variables. If you're looking at the same independent variables, it'll be the same test, and it'll all work out. All right. Any final questions before we wrap it up? Yeah?
Very specific comments or questions afterwards.
Okay, yeah, absolutely. Anything else? All right, so that is going to be it for today. So hopefully the stats workshop helped out anybody that has any final issues with their statistical analysis. So definitely, if you haven't already, go to IU Anywhere, use that, run SPSS, check the YouTube videos for your specific test, check my PowerPoint files for the specific test that you're doing. SPSS is going to do a lot to get your results section completed. And for anybody that submitted their URC abstract at this point, congratulations, well done. For anybody that resubmitted their URC abstract back into Canvas, so I did mention to a few students that let's go one more time around, make the changes, send it back, I'll review it one more time. I will get to those tomorrow morning. All right, so it's just been a hectic day today, but I'll get to those tomorrow morning, so we'll still have enough time to submit them before the Friday deadline. And just to put you at ease even more, the Friday deadline is highly flexible, and they will accept it on the Monday. All right. So anyways, but we'll try to get it in by the Friday. All right. And I will get to those as soon as possible.
We're still able to meet tomorrow.
Yeah.